Hello my friends, and welcome to Inside Out Electronic channel. This is Uncle Misha, and today we have this big TV and it is broken and I have a chance to fix it. So let's try to do it together. So what is the issue with this TV? So I'll show you. So let's start first of all, what kind of TV is this? This is Sony Bravia 50-inch TV. It's I think it's LED. It's still pretty heavy, so it's probably dated 2013, dated about 2013. So it's a relatively old TV. So it model number is 50 KDL 50EX645, and it doesn't work. So today we're gonna try to analyze it and see if we can fix it. Also, I have this nice remote which comes with it. So a remote works. Well, I think it is working. At least it has batteries. So let me power this up and I'll show you what's the problem. So here we are. So if you really pay attention to that little corner right here, you see that red light is blinking, and it is blinking 6 times. We see it stopped. Now it's gonna do 1, 2, 3, 4, 5, 6, stop. And then it's gonna continue after a while. So we just keep continuing, and but it also reacts to the remote. Look at this. If I press it, again, does nothing, goes green, and after a while blinks, and go red again. Well, it usually takes shorter than that. And now it's blinking 6 times. So story essentially continues. So how do we diagnose what's going on? There is a very useful table online which actually tells us what those blinking codes mean. So we can take a look what do we think we have. So as you see, potentially we have power supply problem. So let's open this TV and see what we can fix with the power supply. So after removing like millions of screws, I finally take off the back panel. So let's see what we have here. So we have 4 main boards. Obviously this is our power supply. This looks like a LED driver board for a backlight. This obviously looks like a main processor board or application whatever server. Application processor and stuff, like which actually process all the inputs, outputs, signals, and yada yada yada. This is brains essentially. This is Wi-Fi board right here, and this is TK board, which essentially drives the panel. So that's a light. This is a LCD driver itself. So like a signals goes via those LVDS cables, and this is probably power, I assume, for the TK board, and to drive the panel itself. So 2 speakers bottom there. Also I kept this thing on the base because it's for the convenience. And right there in a very you don't even see it properly. Over there in the corner we have some extra controls. So we figured out, or we assuming that this is the power supply. So we first of all have to check output voltages. Some of the voltage, I don't have schematic of this guy. Some of the voltages are marked on this power supply. So let me get a little bit closer and we can poke around. Right, so here I have my multimeter and here's the power supply. We're gonna hook up this to the ground. I assume this is ground. And right here we have multiple, so this connector goes to the processor board, as you saw on the wider angle shot, and this one is for LED driver. So here it says it has, is my probe crooked? No? Like crooked. So unregulated 24 volt. So this bunch of pins right here are supposed to be just ground and 24 volts. See, here we have 35 volt. Oh, you don't see that. Let me first probe here, and then we're gonna go to the LED driver board. So we're gonna probe DC. So we're gonna probe if we have that 24 volt right on this power supply. Also, we're gonna probe that, and then we have 3 volt. But essentially, I do believe the 3 volt is going there because the main logic board is actually operational. It reacts. It actually talks to the power supply and things like that. Also, as you see, let's talk about power supply quickly. Obviously, this is switch mode power supply. It has single big ass capacitor right here, 450 volt, 82 microfarad, very nice. Bridge protection, very nice protection. It is, by the way, it's unplugged. This is the fuse, and then we have our CL interference filtering, very nice too. We have two transformers, right? Sorry, two transformers. This is a filtering choke, I believe. This is not a transformer. Common mode choke. Those I honestly do not know because I don't have a schematic, but this is 24 volt and probably something else, because one of them is supposed to be quite powerful to drive this huge LED panel. So I'm not sure which one of them. Unfortunately, if someone have any schematic of this guy, I would be really appreciated. So I could not find anything for this matter. So I'm gonna be just poking blindly, measuring some resistances and things like that before I actually make a conclusion what is going on. At least we can check for output voltages and see which one of these transformers drives what. But clearly we have here 12 volt, audio 12 volt, dimmer, like so this contact, like it's actually explained right here. So there is also unregulated 12 volt. Okay, so we have 12 volt, 3.3 volt on this connector, T-con, it says on. So it's also signal to drive T-con, and also here backlight error, ground, and unregulated 24 volts. So we can check all those voltages right here. So let's power it up and see what we have. So we have our guy power. So be very careful when you poke around live switch mode power supply. So first let's check our 24 volt. So this is our ground. Obviously it is ground. I just checked if I connected to the right grounding point. So when I did that, it went to 0. So I am fine. So let's check 24 volt. It is not showing 24 volt. So looks like we do not have 24 volt for some reason. So let's check for some other voltages. It will be easier to check on this connector. So we have 2.9 volts, so 3.3 volt is fine. Okay, regulated 12 volt. We don't have regulated 12 volt. Okay, so we have only 3.3, so probably that's why main controller is working. 12 volt is no go, and 24 volt is no go. And I assume this signal backlight error is 0. So obviously this is ground and backlight is 0. Not sure what the other pins are. Okay, BL on, 12 and 13 is not connected. So there is also BL on somewhere there. Yeah. So let me double check again. So we do not have 24 volt. We do not have 12 volt. So that's the thing which we have to figure out, why we do not have those voltages. So 12 volts, as I understand, only for audio, and 24 volt for the backlight. So now we have to pull this power supply out of here and see what's going on. So, okay, now we have our power supply right here on the bench. So let's see what could have happened here. So make sure when you do that, make sure all capacitors are discharged. So first of all, let's do a sniff test. Like, we try to sniff out any burns. So I'm gonna try to kind of sniff and visually inspect the board to see if anything is, you know, charred, burned, broken, busted. So, but from what I see right here, I don't smell any like burn smell, and I don't see anything broken, especially under those heat sinks right here. So you have to see those big transistors or diodes. So on this side is going to be mostly diodes, big diodes, and those a transistor. So yeah, you see D240, D248, D240B, and the big one here, where is it? Like where is it? Okay, here. Where those actually transistors, one number 1, and then this is diode here. Yeah, it's a transistor and a diode. So yeah, so there is nothing really. Sniff test is passed and visual observation is fine. Our fuse is fine, obviously, MOVs are fine. So let's take a look at general construction of this board. So over here we see oh, by the way, this is Delta power supply. So Delta usually produces good power supplies. It's made in China, designed in Taiwan. The revision is 00, and it was built in 2012, June 28th manufacturing date. So it's 10 years old, more than 10 years old power supply, or actually the whole TV is pretty old. But I mean, still, there is no issue with this, should not be an issue with this TV. Okay, let's take a look where our 24 volt rail goes. So I think 24 volt rail is here, and it goes through this with ferrite bead kind of jumper right here, through those guys, right here, through this inductor, or right here, and it goes here. Right, so this is pins of a transformer. Okay, the ground for this, right, it goes here, right here. Okay, so here is ground, the jumper link, I assume, and the diodes, and what is this, and transformer. So clearly those diodes are responsible for rectifying 24 volt rail, and those two capacitors, these guys, so they are 35 volt, 1000 microfarads, and here is the choke, and here is the diodes, right? No, these diodes, two big ass diodes. So this part is responsible for 24 unregulated for these guys. So I also see here 25 volt guys and 10 volt guys. So these probably 3.3 volt kind of rail, and this one probably 12 volt rail. Here is another diode, probably this looks like for 12 volt, and there is much more stuff going on for 3.3. Okay, so looks like this transformer is responsible for 24 volt rail. So we would have to check on this side to see what's going on primary and on secondary. So we will start obviously on secondary to see if there is a voltages on this transformer. But judging by the simplicity of circuit here, it'll be nothing right here. Right, so we would have to check if anything on these pins of transformer on the primary, and then put our look around over here on the driver. So I also want to see what kind of drivers are these. These to me look similar chippies, and this one, but potentially this guy has PFC, but I'm not 100% sure. I have to take a look what are those guys. Alright, so here I have some notes about those chippies, what we have here. So let's start with this guy. So, well, essentially this guy and this guy are cousins. They are very close to this QS02G and QS03G. This is Infineon pulse phase modulator driver. So this probably works with this transformer and driving these transistors, and this works with, there's another transformer like over here, and drives this transistor right here. this guy, which is over here, this is PFC controller on semi. So yeah, this power supply has PFC, which is very good, active PFC. And this little guy is actually op amp from TI LM258AD dual op amp. So I probably used for comparison and saying like the power supply is good, but again, I'm not sure that I'm gonna trace it all, but I would say one of the potential uses of it. So our interest are those two controllers. Well, if this thing is not working, I think it's working. So I'm not gonna touch PFC. So we'll check those two. Not sure if we have to check this one. Probably this one is fine. We have to check this first because it's related to our 24 circuit right here. So let's try to power it up and see what we can measure with this guy. So let's just find some good ground points. Okay, so I won't be able to measure here, obviously, on this side, right? Because I have to think where would be the ground point for this. But on this side, I would be able to measure because obviously they are galvanically disconnected. I would be able to measure first secondary, and then I will think where would be my ground point to measure primary. So let's power it up and try to test our voltages. So here is our 24 volt. We don't have it. So we slow our ground. I'm just wondering what other pins are. Wow, there is nothing really. Oh, 3 volt. We have 3.2 volts. 3.2 volts is here, for nothing else. Okay. Alright guys, so we have measured voltage. There is nothing on the secondary side. So let's take a look what's going on the primary side. So this is our negative of a capacitor. We're gonna use it as a negative reference, and just like this. And we will try to, so this is our, I assume, 24 volt regulation circuit. So it has, let's see if this little guy is supplied with voltage, but also it has this voltage sense pin. So this number 5 right here. Okay, so it's supposed to have, it says it reads 92 volts right here, and this resistor I think goes from here to over here. Wait, what? It reads nothing. But let me check also other things. What's on number 1? Nothing. What's on 8? Nothing. What's on 7? Nothing. What? Is it faulty chip? 7 is actually VCC, so this guy is not powered. It's interesting. Clearly we have issue with this guy, so let's check what's going on with this guy, just for comparison. So, okay, on similar pin we have 160, which is weird too. It's not rated that high. Okay. So we have 11.5 volts, which is connected to pin 7. So this guy is powered, this guy is not. Let me think about it. Okay, so I just read that this over here, this pin number 5 is actually voltage sensing. If this is 0, that means that this guy is off. Okay, so why here 167? I do not know. Maybe I cannot measure it properly. So something is wrong on this side, and seems like I have to trace it from here to further down. Here's a whole bunch. It looks like resistor divider right here. Yeah, so there is 120. Okay, there are several resistors bundled up together. So what is this? 2704, 2704, 2704, and this guy R602. Let me shut it down. Let me shut it down, and I can measure stuff now freely. Okay, there is a whole bunch of resistors, and here's a bunch of resistors as well. Okay, so write this 240 kilo ohms, 24 kilo ohms, 24 kilo ohms. It's like, looks like, right, 24 kilo ohms. Let's go here, jumper and positive. Okay, so okay, I see now. That's actually mains voltage. Rectified goes right here. And let me trace this little guy here. 0 ohm link. Okay, here's the same, probably similar thing for this chip. There is a whole bunch of it, series of resistors right here, and there's a jumper which goes to this series of resistor and this resistor. So we have to trace all this one. So let's see. So let's switch to resistance. Let's make sure our capacitor here is discharged. Probably the most dangerous thing at the moment. Yes. Okay, it's off. This capacitor is discharged. Let's measure resistances. 2.7 mega ohm. Wow. Yeah, what the heck? It reads 2704. 2704. Okay. 270. Okay. Okay, 27 mega ohms, 27 mega ohms. Let's assume this is another resistor. Whoa, okay. Okay, looking like we have a problem with something right here. It's hilarious. It's funny that these guys are SMD resistors, and this one looks like... Let me detach this from here. Where is it? Where is this guy? Oh. It's under here. So I have to pull this guy out and see what the heck is going on there. Okay, I think I've unsoldered this little gentleman right here using my soldering wick. Don't have really good soldering gun, so desoldering gun, so I have to use what I have. Hello, come out. Okay, so here's our resistor. What kind of value is this? So it looks like we have a red, purple, it's weird looking in this kind of light, and green. So it's 2, 7, and 10 in the power of 5, so 100,000, 2.7 mega ohms. And these dudes are 2.7 mega ohms as well. Interesting. It's like a network of 2.7 mega ohm resistors. Okay, let's measure this guy. Hilarious. How this thing can be busted, and it's 5% tolerance resistor. What? Okay, wow. Okay, well, at least we can try to replace this guy and see where it's gonna go. Ta-da! So I was lucky to get my 2.7 mega ohm resistors pretty fast, and I bought like a bunch of them because I actually do not have any resistors in this range at all. So like I have 1 and 10 mega ohms in my collection, so now I'm gonna have something in between, and this is 2.7 mega ohm resistors. You're gonna pull one here. It's a nice resistor. It's actually quite beefy, beefier than the other one. So maybe it's gonna last longer, I do not know. This is still quarter watt resistor according to the manual, 5% quarter watt, but it's for some reason it's much bigger, right? Let's look at the size difference. Whatever. Maybe this was not quarter watt. So now is the question, how do we put it in there? So let's first try to measure its resistance actually, to see how much it is in the range. I think it's pretty close, 2.6 something, to these guys. Well, as much as I can measure them in circuit, but I can't measure them in circuit because these guys are open circuit, open-ended essentially. Yeah, it's good enough, right? It's good. It's gonna work. So now we have those resistor. Come here. Holes pretty clean, right? So now what I have to do essentially, I would like to replicate using my little pliers here the other resistors lead kind of shape, like that. And maybe on this side just like that. Okay, so we are bend the leads of the resistor. Now I'll try, well, probably I won't be able to do so because I don't wanna. Wow, it's impossible. It's pretty much, look, who come up with this ingenious idea? Yeah, I don't know. So what I'm gonna do, I'm gonna chop this side a little bit and probably chop this side a little bit, not that much, like that. Okay, yeah, the much thicker leads here. So, and somehow we'll try to fish it in there. Just, you know, I could have done it on this side, but I don't know, feels like I'm gonna do how it's supposed to be. Almost there. Okay, this needs to be bent a little bit backwards. It's not easy, but I'll do it. Ta-da! Okay, it's actually easy. It's not that bad. Alright, I don't know if you see it. Here it is. Here it is. It's in. This resistor is properly in. I'm not sure. Maybe this resistor failed because of the heatsink. I do not know. I hope this resistor from Stackpole Electric, made in China, will survive. Well, and for like, I mean, luckily like a whole bunch of them. If something I would be able to replace them. And now it's time to actually solder it in place. So let's do it. My favorite soldering iron here, and flux. Yeah, if you like the soldering iron, you can take a look at my video 300, and I'm gonna just blip plop bloop. Hey. Nice, done. Shut it down. Okay, so we need to cut this longer lead right here. If I find my side cutters, which I left somewhere else, I will cut this lead here and gonna power this thing up to double check if this chippy is going working, and then I'm gonna check for voltages. If these voltages, this 24 volt and 12 volt, 24 volt unregulated and 12 volt for audio regulated is good. If it's good, okay. The very important thing to throw away those resistor thingies and make sure they're not gonna short anything. Okay, let's switch to voltages, and yeah, I'm gonna cut this lead and I'm gonna connect it and test it. Okay, I've done some snip. Now it's nice and nothing. Let me double check other side. And nothing extra protruding here and here. Our resistance should be resistor should be good. So let me find this lead. Here's our lead. I'm gonna just I'm gonna probably turn it around. Connect. I'm gonna shut down here. Okay. Okay, we have powered it up. So here's our negative. Here's our pin number 5. Has some voltage. Some weird voltage. How about this pin? I'm not following why here is 0.6. I'm not following. Well, nevertheless, let's just check voltages. It's weird. I thought here is going to be something similar to this one. There's nothing else that's broken here, or I'm just like being crazy, not understanding how this thing works. Alright, so let's just do this to see if we have 24 volt right here. We do not, which sucks. Do we have 3 volt? Oh, we don't even have 3 volt. No, we do. Okay, 3 volt we do. 12 volt, somewhere here, don't remember where it is exactly. We do not have 12 volt, but we have 3 volt. Okay, so there is a very important thing to understand here. So this thing not gonna power properly without a power good signal on the connector. So unfortunately, I won't be able to test it like this. So what I have to do, I have to actually connect it to the TV and test it that way. Because microcontroller board gonna provide a signal which actually allows everything else to kick in. So that's something very important. So let me mount it back on TV and see how it's gonna fly, or not. Right, my friends, so here is the moment of truth. If this is little simple fix worked or not. So I have everything connected, but not powered up yet. So let's see what's gonna happen here. Alright. Let me see if we have 24 volt. We have like something. A little bit of volts, but not 24. That's interesting. We don't have 12, but instead of 24 we have like okay, we don't have anything. That sucks. Let's see what we have on the front here. Oh, here we are. Looks like we hear buzzing, and we have 24 volts, and I think I see light peeking through these things. Yeah, baby! Looks like we fixed it, and I had to just power it up just like that. And now I can shut it down. Can I? Boom! It's shut down. Okay, so I think we have a success. Success by fixing a little resistor which resides just. Wait, I think just right here, 2.7 mega ohm resistor replacement. So now we've this ever gonna happen again, I'm gonna know how to fix this TV. So I hope this video was actually useful to someone. I hope you have handy 2.7 mega ohm resistor lying around. Otherwise, you would have to order it from any retailer you usually buy, like DigiKey, Mauser, Amazon, eBay, whatever. Any kind of 5% 2.7 mega ohm resistor, gonna cut it. At the end of the story, you can just make several resistors just to make 2.7 mega ohm, like in series, you know, 1 + 1 + 700 kilo ohm or something like that. Yeah, here this is it, the successful fix. Let me turn the TV around and see what's happening there, if it works or not. Maybe just a backlight, nothing else is happening. So let me do that. I have to move this actually quite beastly TV and we see if it's actually showing anything. Okay, let's shut it and turn it around. All right, I have turned the TV around. You probably see my reflection right here, barely. Here's my fingers, la la la. Sorry for the glare again, and let's power it up. Okay, I did powered it up, and what? Ta-da! So yes, it's sort of kind of working. Okay, has no signal, no HDMI input. Yeah, well, it just does the business. It does the business. Netflix. Hey. Yeah, I'm not sure how to use this remote. It's I never had any Sony TV, believe it or not. I'm just poking around here. Wide. It clearly it is working. So volume, channels, internet apps. Please wait and try again later. Input. I'm not sure what I have to set here. PC. Okay, well, kind of weird that it's not working. This is weird. Why it says please wait and try again later? It's just like it's... But anyway, it's not the problem of this particular video. Here we did fix that TV. It's the main thing, right? And I'm pretty happy that we were able to fix it. Obviously, it's not as nice TV as any modern TVs because it's like 10 years old, but it's still 1080p. It has bazillion of inputs and like it's free, well, cost of a resistor or 25 resistors to be sure, and shipping. So, but yes, I have operational TV, and now I can do whatever I want with it. But very main thing, we saved this TV from the dumpster, and the person who gave it to me said, okay, well, if you're not taking it, I'm gonna just throw it away. So I decided to, well, I mean, I'm gonna take it, I'm gonna fix it, I'm gonna either keep it or, you know, give it to someone else who actually need a TV. So I think that's it. Thank you guys for watching. Please stay tuned for any other repair videos and see you next time.